Hello and welcome to this film, which is all about equilibrium constants again, and in particular how we can change the value of an equilibrium constant without changing any of the conditions of the reaction. And that might sound a little bit strange because although we've learned by now that equilibrium constants won't change if you change any condition other than temperature, we'll see in this film that we can change the value of an equilibrium constant without changing anything about the reaction other than the way we represent it. Okay, so that might sound a little bit vague at the moment, so let's just have a look at a quick refresher really of what we mean by an equilibrium constant. So if we write a reaction as A plus B makes C, then our products are on the right, our reactants are on the left, and when it comes to writing the equilibrium constant expression, the products go on the top of the fraction and the reactants go on the bottom of the fraction. And if we've got some stoichiometric coefficients, then we put some powers into our expression. And that shouldn't be anything new to us at this stage. But what we might not have thought about is what's going to happen to that equilibrium constant if you represent your reaction in a different way. Now, just because we write the equation for this reaction in two different ways, it doesn't mean we've actually changed anything about the system. So if I've got some A and B in equilibrium with C, I could write A and B turn into C and C turns back into A and B this way round, or I could write it that way round. And it's not important which way round I write it for what the physical reality is in my system, but it is very important for my equilibrium constant expression. So if I write it this way round, I have the C in the numerator. If I write it this way round, I have the C in the denominator. And that might make it seem like, well, hang on, now K is the inverse of what K was before. And that's absolutely right. K is now the inverse of what it was before. And that makes it seem like something has actually changed on a physical level. But it hasn't. All that's changed is that we have just written an equation the other way around. And remember, us describing things by means of an equation is just our way of representing something in nature. Okay, it's not necessarily the truth, it's just the way we represent things. So if you reverse the reaction, we invert the equilibrium constant. So if the equilibrium constant here was x, the value of it was x, then here it would be 1 over x. Okay, simple as that. Now we could also multiply the reaction equation. Okay, so let's say I had some A and B in my jar with some C and they're in equilibrium with each other. I could change the equation without changing anything about what's going on in that jar. Okay, so it's just as valid to write that 2A and 2B make 2C as it is to write A and B makes C. But if I write it differently, then my equilibrium constant expression is going to look different. Okay, again, without anything having changed other than the way we represent things. Okay, because the equilibrium constant is defined in terms of a reaction equation the way we write it, then it's going to look different if we write the reaction equation differently. So if you multiply your equation by a factor, let's say 2, then the equilibrium constant, let's say it was x here, would become x squared here. Okay, because we've squared every term. Again, nothing has changed in reality except for we're going to get a different value for K, but that's just because we're representing the reaction differently. Okay, so hopefully you've seen now some ways we can change the value of K without actually changing any conditions. And this doesn't violate the rules that we've covered before, that K can only change if you change the temperature, because back then we were looking at K as a description of what was actually going on in the system. Here we've been looking at how K and the definition of K is actually based on the way we wrote a reaction. Okay, hopefully it makes sense. If you've got any questions or comments, then please feel free to come and see me or to post a comment on YouTube.